So, um, as I suggested, the OAIS model isn't just for people building digital libraries. The ideas, the concepts that it brings, and the questions it makes you ask are helpful at all levels in terms of data management planning. Particularly data management planning for the longer term, even on the scale of a single researcher. Questions that you as a researcher generating data should be thinking about: designated community, who's going to want to look at my data in the future, and thus what information do I need to make sure I capture so that my data are comprehensible. Is it possible that I can make my data accessible to the wider public, or really is it only specialists in my field who will be able to understand it? In our modern world of increasing public engagement with science, these questions become important. In terms of archiving, archive information package, what's the best format for me to store my data in, and how long-lived are those formats, and when will I need to think about migrating them, or is my format going to last forever? How do I keep metadata and data together? It can be the case that if data gets separated from metadata, then both parts become almost unusable. And so keeping them wrapped up in an archive package is an important thought. And if somebody asks for my data, should I just give them the archive information package, or is there a better way to share it? And of course, the long-term question: if I do this, if I just put it on the web, will it still be there in 3 years' time? Never mind 100 years' time. Even 3 years ahead is potentially quite a challenge in many circumstances. Many of these questions, of course, are beautifully illustrated by the data sharing panda. And if that reference is lost on you, please go ahead and follow that link. So there are a couple of technologies I mention here which are particularly useful and widely used in building preservation archives. DSpace is one of them. These are open source packages I'm going to just touch on. So DSpace is typically used, certainly in the United Kingdom, as an institutional repository, a university data library, for instance. It does the sorts of things that you would hope. Helps you record and capture and ingest materials, including metadata, and provides access to them and facilitates long-term preservation of them. The DataShare repository that the University of Edinburgh provides for its researchers is a good example of a fairly large-scale DSpace deployment. Fedora, the Fedora repository, the Flexible Extensible Digital Object Repository architecture, is another commonly used set of building blocks for building archives. It's a little bit more of a framework and a toolkit than DSpace. It has an abstracted model architecture and abstract model of digital objects, supports a number of useful things. Versioning is included, which is handy. Object-to-object relations. And again, very popular in the open source community for building these sorts of long-term repositories. So I've emphasized a little bit the OAIS model, but OAIS isn't everything. And it's increasingly challenging to make use of the OAIS concepts in today's world, particularly with respect to data which are distributed, increasingly distributed, and often published on the web. The web is a tremendous information resource, and increasingly people are using it as a mechanism to distribute, to disseminate scientific findings, scientific data, but it doesn't fit cleanly into the OAIS ingest, manage, disseminate model. There is no central data archive when it comes to the web. Keeping copies is perhaps easier. You can spread them across the web and make use of that distributed nature to create systems which do indeed take multiple copies and help keep things safe. The LOCKSS system from Stanford University Libraries is a good example of one of these. Lots of copies keep stuff safe, is what that stands for. It's designed as a peer-to-peer, very robust system for archiving scientific publications and journal publications. That's what LOCKSS was invented for. It isn't quite the same thing as the web. It uses a distributed model designed to be very robust against outside attack and data corruption. The internal service vote on content integrity. But it was designed for publications, and its scalability to large-scale datasets is a different question. So this idea of trying to make sense of different archiving models in a web-connected world is exercising a lot of people at the moment. The web itself is particularly robust, resilient. The protocol-centric nature of the web makes it an extremely robust information architecture, one of the best we've ever built. Publication is dead easy on the web. Anyone can publish anything. Search and indexing is harder, although there are a number of large companies out there who will help you find things. One of the big drawbacks of the web is provenance and quality. If anyone can publish anything, well, anyone can publish anything. Particularly, anyone can publish anything which looks like it's barely official and indeed might suggest that it has a degree of scientific weight behind it. It's published in an online journal which looks very respectable, and actually it might just be made up. It's quite difficult to tell. That's one of the biggest challenges of science on the web, is keeping track of provenance and quality, and is potentially a role for the journal publishers who are finding that the web is undermining their business model, perhaps, in terms of publishing things in journals. If many things are published online, what's a role for a traditional journal publisher? Well, keeping an eye on the quality could well be a role that they should take on there. The web is great for publishing things. You can replicate things on the web, but it doesn't happen automatically, and you need something else there. The web needs something else, and there are new technologies on the horizon. The resource sync protocol, for instance, might be a way to do that. And keep things stable, keeping things accessible, keeping URLs from vanishing and returning 404s. That's the main challenge, and that doesn't come for free. That requires people just to put in some work and keep the URLs from disappearing. You might think peer-to-peer networks, things like BitTorrent, might be an optimal way to share data across the web. BitTorrent, by its very nature, will recreate multiple copies of a particular set of files in a highly distributed way. Well, yes, it does. But again, search and indexing, how do you find these things? I'm not sure relying on the Pirate Bay is the right way to preserve the scientific record. And again, provenance quality versioning can be perhaps more of an issue in peer-to-peer networks than even on the web. And it shares many of the same problems of the web in terms of provenance, in terms of stability, etc.